next speaker is Robyn Silbey. Here's her 3 statements. Robyn's bowling average is 152. Robyn's high school grade point average was 1.6. Robyn briefly worked as a bartender.
I'm really anxious to follow Eric. Mike? I get 2?
Yeah, put that somewhere.
Hold on, please. Can you make that not happen?
Oh,
yet?
it's not happening.
Okay.
Okay.
Yep. No. Hi, it's a pleasure to see you today. I'm going to have to talk really fast right now. We are going to be modeling a 1 million model, and we're modeling mathematics using this fabulous quadrille paper as our tool, but we are also going to be doing a math model. The kids encountered a goal when I asked them for Maryland Math Month what they would like to do to show 1 million in the building. We thought about all kinds of different manipulatives, but we settled on this fabulous quadrille paper because 100 square units is a square inch. So we figured they'd be really tiny, and that's why they chose it, and because we could collect them very quickly. As the kids proceeded through this idea, they found out they had 2 issues. Number 1, in order to give everybody in the building a fair share, they'd have to divide. But they also needed to figure out what to divide by, because they didn't know how many grown-ups and kids were in the building. So they went out to the building and they took a survey of all the kids, pre-K through 5, and every paid adult in the building. The total was 498. So they came back and they said, okay, we've got 498. Now we've got to figure out how many each person gets. So they divided 1 million by 498. The quotient was 2008. So they figured out, okay, everybody gets 2008 squares. What's that going to look like? A long strip or something else? Well, they said, no, we're going to make it a square. And I explained to them, okay, you'll need to find the square root to find the side length. We did that. Square root was 44.8. We rounded that up to 45, and every kid and adult in the building got a 45 by 45 unit square, compliments of the children cutting. 1 per person, just thought I'd mention it. Okay, so now we decided, okay, now in order to launch this, lots of little kids don't know what 1 million is. So the kids went out into the classrooms and read some books to give some kids another reference of 1 million. And then after that, we gave them the quadrille paper and the direction of you can make it any way you want. Use crayons, markers, colored pencils, any design you like. Good cue there. Then we set a due date only about a week later. How long does it take to color a square? And if you wait a month, you're not going to get them back. So we had to make a short turnaround time, and we ran around to all the classes, and then the kids went around to all the grown-ups to collect them. Well, we got back and we counted them. The kids counted them. And it wasn't 498. So they kind of had to figure out, well, you know, what's too little? What's too many? How are we going to make this work? So they decided to color extras in to make 498 to get as true as they could. And then they assembled them on black bulletin board paper. And we just kept glue sticking one after the other to make this magnificent quilt. So we showed the kids right outside the room 1 unit, 10 units, 100 units, 1,000 units. Now guess. How big is 1 million units? Well, when they walked into the cafeteria the next day, they found out that it was the width of the bulletin board paper and the length of the long side of the school cafeteria. Mammoth. They just couldn't get over how big it was. The adults as well. $1 million's a really big number. The kids really enjoyed sitting around at lunchtime, looking at it across the wall, and when they finished eating and cleaning up their food, they were able to walk over and take a look at everybody's beautiful designs. And we found all these wonderful artists that we never knew existed, such as Cecil, our beloved custodian, who became a rock star artist after we all found out who he was. Now, one little note that I want to talk to you about, and that's the input-output rule. Sure, it took a lot of time and effort to make this happen, but when you think about the rewards, the togetherness and team building of the school, and all that the kids learned about $1 million and the size of it, it was really worthwhile. So my first question to you is, how could you massage this idea to make $1 million model in your building? And secondly, wait for it. And secondly, what are some other math models you can make using Dan Meyer's wonderful 3-step process: encountering or motivating goal, mathematizing that goal, and then seeing the results of that mathematization? I'm happy to help. There's my info.